Okay, we're going to try another one, a derivative of an inverse trig function that has a complicated inside, so definitely a chain rule situation, and a little bit going on there because we've got a fraction. So feel free to try this one on your own and then check your answer or follow along. So I'm going to go ahead and do this in terms of u, sine inverse of u, where my u is the 3 over x squared. So let's start with big ideas. I've got a trig inverse, and we have a derivative for that, and that is 1 over radical subtraction and square root 1 minus u squared. Whoops. There we go. And then I've got to do my derivative of my inside. So I'm probably going to rewrite this as 3x to the negative second, so I can do the derivative. I really don't need quotient rule for that because I've got a constant in the numerator. So my u prime is then going to be negative 6x to the negative third, which is a negative 6 over x cubed. Okay, so now I just need to put this together. So my derivative with respect to x is going to be my 1 over radical 1 minus, and my u that I'm squaring is, remember, this over here, 3 over x squared. And I guess I really don't need, whoops, really don't need all that. And then I got to multiply by the derivative of the inside, u prime. So we can go ahead and write that a couple ways. We could actually write it as times negative 6 over x cubed, and you might prefer that. The other option is to put it in the numerator, and it really doesn't matter. I'm going to end up simplifying it. It's just a matter of whether I have it as a complex fraction with one thing in the numerator and a complex denominator. But yeah, if you don't believe me, try it both ways. I'm going to go ahead and be consistent with how I did the other one, and I think that might be a little bit easier to follow. So I'm going to put it in the numerator and multiply it times the negative 6 over x cubed. So let's go ahead and put it up here. And then what we're going to end up with is a fraction inside of a fraction in the numerator and fraction in the denominator. So let's go ahead and simplify the denominator, same as we did last time. So I'm going to end up with 1 minus 3 squared is 9 over x squared. Oh, whoops, I've got 3 over x squared there. I just forgot to write the square. It was right here. So let's fix that. It's actually going to be x squared squared. So I'm going to end up with x to the fourth. So 9 over x to the fourth, and I've got a 1 over 1 here. I want to subtract the two fractions. So I'm going to multiply by x to the fourth over x to the fourth for this fraction right here. And when I do that, that's going to be x to the fourth over x to the fourth. Then I can rewrite it as square root of x to the fourth minus 9 all over x to the fourth, because they have a common denominator. And ultimately I'm going to separate that into two radicals because I can do that. Square root of x to the fourth is x squared, and we really don't have to worry about the negative sign here because we don't have an issue with it since we're going to have an x cubed. I'll show you in a second. So let's go ahead and rewrite. I'm ending up with, in the numerator, negative 6 over x cubed over square root of x to the fourth minus 9 all over x squared. And again, we can simplify that later, but I just went ahead because I saw square root of x to the fourth here. I thought I could go ahead and simplify it. Multiply by the reciprocal, so times x squared over square root of x to the fourth minus 9. All of that cancels, and I'm left with just this. Not too bad, but I think I can go a little bit further. So let's go ahead and say I've got negative 6, and my x squared here is going to cancel with my 2 of my 3x's that I have in the denominator. Notice that So the reason I mentioned before we're not going to have to worry about the absolute value bars is I had x squared, that's always going to be, okay, we had square root of x to the fourth, which is always going to be positive. I have x cubed in the denominator, so if I have a negative number and I'm cubing it, that's going to be a negative. So if I simplify that to 1 over x, which is what I'm really doing here, if my x is negative, that's going to be a negative answer, and I'm okay with that because it should be negative, because my x squared over x cubed would have been negative. So I'm okay there to go ahead and not worry about absolute value bars. X over radical x to the fourth. Minus 9, I can't take the square root of those terms separately, so I'm done. That's my answer. Final answer. Hopefully that helped. I am going to do a couple more examples, but feel free to try them on your own as well.